Welcome right back to the Explainer. We so often think of mathematics as just this rigid collection of equations, right? Or just abstract numbers floating on a chalkboard somewhere. But what if I told you that math is actually the hidden code of our very existence? From the literal floors we walk on to the groceries we buy, all the way down to the fundamental, vibrating fabric of the universe itself, there is this incredibly beautiful hidden geometry dictating how everything works. Today, we're going to visually decode that reality, and we're starting with a puzzle that baffled the greatest mathematical minds for over half a century.
Okay, let's dive into this. Because for 50 years, there was this massive mathematical mystery. Experts were absolutely convinced that a specific geometric concept was entirely impossible. The question was actually pretty simple. Can a single shape cover an infinite flat surface, like a giant floor, without ever creating a repeating pattern? The consensus among all the experts was a resounding no. They believed that if you had just one single shape, eventually the pattern it created would just have to repeat itself. It was thought to be an unbreakable rule of geometry.
But here is where the story gets incredibly cool. Just last year, that 50-year-old impossible rule was completely shattered. And honestly, the most amazing part? It wasn't solved by some massive supercomputer or a giant team of Ivy League professors. No way. A hobbyist mathematician completely upended expectations and proved all the experts wrong. He discovered a shape that does exactly what everyone thought was impossible.
So, meet the Einstein Tile. And just a quick aside, in this context, Einstein actually translates from German as one stone or one shape. Specifically, this deceptively simple geometric shape is known mathematically as the hat or the specter. It is what's called an aperiodic monotile. That basically means you can take millions of these identical little hat shapes, lock them together, and they will stretch on to absolute infinity without the overall pattern ever looping or repeating itself.
Let's do a quick deep dive into this comparison to really grasp how mind-bending this is. Think about standard bathroom tiles for a second. Maybe they're squares or hexagons. They represent periodicity. Every few inches, the exact same layout repeats. It's perfectly predictable. But our new hat tile, that represents aperiodicity. It literally creates order without repetition. The tiles fit together flawlessly, leaving zero gaps, but the design they create shifts and evolves endlessly. It's kind of like a song that stays perfectly in rhythm and key, but never repeats the exact same chorus twice.
Now, you might be wondering, okay, why doesn't never repeating floor tile actually matter to me? Well, this isn't just about fun interior design, it's actually about the fundamental structure of matter itself. Understanding aperiodicity helps us understand things called quasicrystals in nature. These are atomic structures that are highly ordered but completely non-periodic, and they are unbelievably useful. Quasicrystals are used to manufacture everything from the durable coating on your everyday nonstick frying pans to highly advanced experimental materials used for spacecraft. So the math of this funky floor tile is literally the math driving cutting-edge engineering.
Section 1. Hidden order in daily life.
Now, what's really interesting about this is we've seen how mathematical rules dictate physical shapes. But let's shift our focus to the hidden mathematical rules governing the human-made systems we interact with every single day. It turns out that completely mundane barcode you scan at the grocery store is actually a marvel of pure number theory. It relies on a concept called congruence. A standard UPC-A barcode consists of 12 digits. The first 11 identify the manufacturer and the specific product. But that 12th digit sitting way over on the far right, that is the check digit, and it exists purely as a mathematical failsafe to ensure the scanner didn't misread the code. So here's how that algorithm actually works in practice. To calculate that check digit, a computer multiplies the first 11 digits by alternating 3s and 1s. Then it adds all those products together. Finally, it uses something called modulo 10 arithmetic, which is essentially just looking at the remainder when divided by 10 to determine exactly what that final 12th digit must be to make the whole sequence valid. If even a single number is mistyped or misread, the modulo 10 equation fails and the scanner beeps an error. It's basically a hidden mathematical shield protecting all of global commerce.
Section 2. Chaos and the butterfly effect.
So human systems use math to create perfect order and catch errors. But the moment we leave structured human codes and step into the natural world, we encounter sensitive dependence on initial conditions. You likely know this as the butterfly effect. In a dynamical system, if you take two starting points that are practically touching, just arbitrarily close together, over time they will separate at an exponential rate. This means a microscopic change in a starting condition causes massive, completely unpredictable outcomes later on. This is exactly why complex systems like our global weather become virtually impossible to predict accurately past a time frame of about a week or so. Those tiny variations in data compound into massive atmospheric differences.
But this gets even deeper when we shrink all the way down to the subatomic level. Classical chaos, like the weather or a swinging pendulum, involves a small change in the position or velocity of an object, resulting in a wildly different path. But quantum chaos introduces the quantum butterfly effect, and this is measured by something called fidelity decay. In the quantum world, it's not just about a particle changing its position. It actually measures how quickly identical initial states completely break apart when exposed to slightly different energetic environments. Chaos isn't just blowing in the wind, it's literally baked into the quantum fabric of reality.
Section 3. Fractals and String Theory.
And this brilliantly illustrates our next point. Now that we've looked at the unpredictable micro level, let's explore how unimaginably simple rules can create infinite mathematical spaces and perhaps even form the foundational fabric of the universe itself. We are looking at the famous Mandelbrot set alongside a zoomed-in section called a period 7 bulb. The Mandelbrot set is generated by taking a deceptively simple quadratic equation, basically taking a number, squaring it, adding a constant, and then repeating that process over and over. By mapping which numbers escape to infinity and which stay bounded, this infinitely complex, non-repeating border emerges. No matter how far you zoom in, new, distinct, and absolutely breathtaking geometric structures continue to appear forever. Pure math literally creates infinite complexity.
This whole idea of a complex reality emerging from elegant mathematical foundations brings us straight to string theory. In standard physics, we generally think of the universe as being made of tiny, zero-dimensional point particles, while string theory replaces those points with microscopic, one-dimensional vibrating strings. Just like a violin string can play completely different notes depending on how it vibrates, these mathematical strings produce different fundamental particles, like quarks or electrons, depending entirely on their vibrational state. To make the math actually work, physicists have expanded this into M-theory, which requires 11 dimensions and introduces higher dimensional objects called branes. It's a breathtaking attempt to mathematically unify gravity and quantum mechanics into one single theory of everything.
To bring our whole journey full circle today, I want to leave you with this profound thought from Stanford University mathematics professor Keith Devlin. He's talking about Euler's identity, which is often called the most beautiful equation in all of math. He says, like a Shakespearean sonnet that captures the very essence of love, Euler's equation reaches down into the very depths of existence.
Mathematics is definitely not just a tool. It is the actual language the universe is written in. And as we saw with the Einstein Tile earlier today, our understanding of that language is constantly evolving.
If these deep dives expanded your mind, don't miss our next breakdown. We're decoding the universe one explainer at a time. So please subscribe right here on YouTube for our weekly deep dives, follow our Substack for the full source documents and study guides, and join our Discord to chat with fellow math explorers. I want to leave you with this final thought. If a single simple shape discovered by a hobbyist can break a 50-year-old mathematical rule, what other hidden mathematical codes are waiting to be discovered right now in the chaos of our world? See you next time.